Okay, so here's the math around the room answers. We'll start off with the special right triangles. And it turns out that this one right here, since it's 45, that means it's a 45, 45, 90. And that follows the phrase, if A is our short side, this is also equal to A. And this is equal to A times the square root of 2. And what number's in the A spot? 8. So that means A equals 8. And B equals 8. Okay. I'm trying to do this with a mouse instead of a pencil, so I apologize for the bad handwriting, but that's what I gotta do. Okay, for B7, this is a 30, 60, 90 triangle. So that means if this was x, D would be equal to 2x, and then C would be equal to x times the square root of 3. So that means C is going to be equal to 7 root 3. And then D over here is going to be equal to 2 times 7, which would be 14. And then finally over here, again, 30, 60, 90 triangle. This one over here was a 2, I think this got cut off in the copier machine. That should be a 2 root 3, I believe. So then that means this one over here, this would be 2 root 3, 2 times 2 root 3, which is 4 root 3. And this last one over here is going to be 2 root 3 root 3. And root 3 and root 3, when you multiply them together, the roots will cancel, and that becomes 2 times 3, which is 6. Boom, and boom. Okay, and solve using the quadratic formula. Again, there's a divisible 1 in front of the x squared that you don't see. So this would be our A, our B, and our C. And we got to follow the quadratic formula of x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and plug stuff in. So this is going to be a negative 4 plus or minus the square root of 4 squared minus 4 times a, which is 1, times c, which is negative 7, all over 2a, so 2 times 1. So that means over here we get negative 4 plus or minus. When you put this stuff under the root, all on a calculator, 4 squared is 16, and negative 4 times negative 7 is positive 28. So 16 plus 28 would give you 44. And that's all over 2 times 1, which is 2. We're going to break up this root 44 into two numbers. That's going to be 4 and 11. 2 and 2. Couples go out, singles stay in. So this is negative 4 plus or minus 2 root 11. Because when couples go out, they only make one reservation, all over 2. And then you divide each of the numbers by 2. Negative 4 divided by 2 is negative 2, plus or minus. 2 divided by 2 is 1, so that's root 11, and that's your final answer. Negative 2 plus root 11, and negative 2 minus root 11. All right. I'm going to go ahead and pull group 2's problems over. All right. So let's go ahead and Pythagorean triples. So if we were to divide both of these numbers by 2, we should probably start off by writing the Pythagorean triples down. 3, 4, 5 is the most common one. But we also have 5, 12, and 13. And we also have, I believe it's 8, 15, 17. So when you divide these by 2, you get 17, and that's 8. And the only triple missing from there would be this guy, 15. So that means this side over here would be 15 times 2, which comes out to 30. Or you could just do a squared plus b squared equals c squared. Over here, again, this is 0.003 and 0.005, so that is actually a 3, 4, 5 combo. So that means our missing piece over here would be 0.004. For part C, let's go ahead and divide these both by a common factor. I believe the GCF is 4. When you divide them by 4, you get the side lengths of 8 and 15. So that means this side over here is going to be a 17 times our common factor of 4, which comes out to a grand total of 68. Okay. And solve using the quadratic formula. Let's go ahead and do it. So we'll do the work over here. Hope that's okay. X equals negative b plus or minus the square root of b squared minus 4ac, whoops, 4ac all over 2a. So negative 3 plus or minus all the stuff under the root. 3 squared is 9. And that's minus 72, so it's negative 63. All over 2 times 3, which is 6. Let's take this root 3 and break it up a little bit. Root 63 would break up into 7 and 9 and 3 and 3. So that means this would give you negative 3 plus or minus. Since there's a negative in front, we'd have to pull an I out of the root. So couples go out. This would be a 3. An I comes out because of the negative. Square root of 7 all over 6. Okay. And the 3, 3, and 6 all have a common factor of 3. So when we divide those out, we get negative 1 plus or minus I root 7 all over 6 divided by 3, which is 2. Okay. Doing group 3 now. Okay. So roots go underground, exponents go up. So this is just equal to q to the 3/7 power. And then this one right here, if you don't see the number, there's an imaginary 2 right there. So this is equal to q to the 9/2 power. Okay. Rewrite the expressions without exponents, then simplify. So when you rewrite this, this is the 3rd root of 27 to the 1st power. And that means what number times itself 3 times is 27? So it's 3 times 9, 3 times 3. So 3 times itself 3 times is 27, so that's 3 to the 1st power, which is 3. For part D, again, this is the 4th root of 16 raised to the 3rd power. Okay, remember, that's the root. That number right there in the top, that's the exponent. So what number times itself 4 times is 16? 16 breaks up into 4 and 4. And those each break up into 2 and 2. So we have one group of 2s, so this is now equal to 2 to the 3rd power, which is 8. Okay. And actually, I'm going to do this down here. Easier kind of to see. 2 to the 3rd power, which is 8. Okay. And then quadratic formula, again, that's going to be our A, our B, and our C. So we got x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's negative 8 plus or minus the square root. 8 squared, 64, minus 12, that's 52, all over 2. So let's go ahead and break up that 52 a little bit. That 52 breaks up into 2 and 26. And 26 breaks up into 2 and 13. Circle the pair. Couples go out, singles stay in. So negative 8 plus or minus 2 root 13 all over 2. And since each of these are divisible by 2, this is now negative 4 plus or minus the square root of 13. Okay, next up is group 4. So, because it says the word square, that means each of these are 90-degree angles, and it's being cut in half, so therefore these are 45, 45, 90 triangles. And the pattern for 45, 45, 90 is if that's x, this is x, and this is equal to x times the square root of 2. Right. So 6 equals x root 2. So let's do x root 2 equals 6. And we want to get x by itself, so we divide both sides by root 2. Roots cancel. So multiply top and bottom by root 2. 6 times root 2 is 6 root 2. Root 2 times root 2 cancels, and a 2 comes out. And 6 divided by 2 is 3, so this is 3 root 2. So that is our x value, which means all of these sides are 3 root 2. So don't forget, area is equal to length times width. And that's going to be equal to 3 root 2 times 3 root 2. 3 times 3 is 9. Root 2 times root 2, the roots would cancel and a 2 comes out. So you get 18 units squared. And then for perimeter, you add all the sides. So that's 3 root 2 plus 3 root 2 plus 3 root 2 plus 3 root 2 for a grand total of 12 root 2. For B, same thing. That's a 90-degree angle, so this is going to be a 45, 45, 90. So that means if that's x, that's x. 14 equals x root 2. Okay. So 14 equals x root 2. Let's divide both sides by root 2. Okay. So x equals 14 over root 2. Multiply top and bottom by root 2. So that's 14 root 2 over 2. And 14 divided by 2 is 7, so that's 7 root 2. So that's our x value, or that's the sides of our square. 7 root 2, 7 root 2. Okay. So area equals length times width. 7 times 7 is 49. Root 2 times root 2 is 2. So 49 times 2 is 98. Perimeter is when you add all the sides together. So 7 plus 7 plus 7 plus 7 would give you 28 root 2. Oops. Okay, solving the quadratic formula again. So we got A, B, and C. Okay. So we got... Sorry. X equals negative B. So that's negative 3. Plus or minus the square root of negative 3 squared. Make sure you put that in parentheses so you don't mess up your negatives. Minus 4 times A times C. All over 2A. So negative times a negative makes that a positive 3 plus or minus the square root. Negative 3 squared is 9, minus 4 times 2 times 1, that's 8. So that's the square root of 1, all over 2 times 2, which is 4. And you can actually take the square root of 1. So x equals 3 plus 1 over 4, which is 4 over 4, or 1. And x also equals 3 minus 1 over 4, which is equal to 2 over 4, and that reduces to 1/2. So 1 and 1/2 would be your answers for part A. For part B, again, x equals negative times a negative 10 plus minus the square root of negative 10 squared minus 4 times 1 times C all over 2A, so 2 times 1. So negative times a negative is a positive 10 plus or minus the square root. Negative 10 squared is 100. 100 minus 4 times 1 times 1 is going to be 96. All over 2 times 1 is 2. Let's go ahead and break up that 96. That breaks up into 2 and 48, which breaks up into 2 and 24. Actually, it might be better if I kind of do my own little side work over here. 96 breaks up into 48 and 2, and that would be 2 and 24. 12 and 2, 6 and 2, 3 and 2. Okay, let's circle the pairs. Okay, so it's 10 plus or minus. There's 2 pairs of 2's, so 2 times 2 would give us 4. And the singles go back underneath the root, so 3 times 2 is 6 all over 2. So the answer to part B would be 10 divided by 2, which is 5, plus or minus 4 divided by 2 is 2, square root of 6. Final answer. Okay, kind of sucks this got cut off, so I'll do the best I can. I think it was a 4. I can't remember if it was a 4 or a 5. I don't have the paper with me. But for A, because there's a plus in the middle, you just combine like terms. 3 minus 1 is 2. Negative 2i plus 5i is a positive 3i. That's done. For this one, you have to distribute the negative first. So this becomes a positive 1 minus 5i. Then you combine like terms. 3 plus 1 is 4. And then negative 2i minus 5i is negative 7i. And for the last one, I want to say it was a 4. So I'm going to do it as if it's a 4. I apologize if it's wrong. 3 times negative 1 is negative 3. 3 times 4i makes that a positive 12i. Negative 2 times negative 1 is a positive 2i. And then negative 2i times 4i would be a negative 8i squared. But whenever you see an I squared, that means that this becomes, instead of a negative 8, a positive 8, and the I goes away. So negative 3 plus 8 makes it 5. 12i plus 2i makes it a 14i. Okay. Same thing for D, just combine like terms. 7 minus 3 is 4. Negative 5i plus I makes that a negative 4i. Distribute the negative. So negative times negative is positive 3. Negative times positive is negative I. So 7 plus 3 gives you 10. And then negative 5i minus I gives you a negative 6i. And for F, because they're being multiplied, you have to FOIL out. You could also do an area model, I guess. Maybe I should show you an area model. So if you did an area model for this one, you'd have 7 minus 5i and a negative 3 plus I. 7 times negative 3 is negative 21. Negative 3 times negative 5i is a positive 15i. 7 times I is 7i. And I times negative 5i is negative 5i squared. So you get negative 21 plus 15i plus 7i minus 5i squared. However, because of the I squared, that negative 5 just becomes a positive 5 and the i's go away. So negative 21 plus 5 is a negative 16. 15i plus 7i is a positive 22i. Whoops. Next shortcut, group 7. Okay. In this problem, because these are parallel lines, these guys are called alternate interior angles. So A right away is equal to 20. To find this missing part of a triangle, all angles add to 180. So that's 180 minus 110 minus 20. And that gives you 50 degrees right here. And this is also alternate interior angle from C. So C equals 50, which means B and 110 are going to be equal to each other because they're on opposite sides of a parallelogram. So B is 110 degrees. And all these angles should add to 180 because they're all triangles. So that's how you can check to make sure you're right. For part B, again, this left side, this right here is a triangle of itself. So you do 180 minus 90 minus 80, and that gives you x equals 10 degrees, which means this has to be 10 degrees because it's marked equal. So if these guys are equal, then that triangles are similar by angle similarity. So that means 80 and y are also equal to each other. And then z and y make a straight line, so z is 180 minus y, which is 80, for a grand total of 100 degrees. And another Pythagorean theorem problem. So x equals negative times negative 6 plus minus the square root of negative 6 squared minus 4 times 1 times 10 all over 2 times 1. That's a positive 6 plus or minus negative 6 squared is 36 minus 4 times 1 times 10, that's minus 40. So that would be a negative 4 under here, all over 2. And you take the square root as normal, but since there's a negative under there, you got to make sure you plot I with it. So that would be a 2i all over 2, for a grand total of 3 plus or minus I. For the last one, so these have to follow the phrasing y equals a x with an intercept, x with an intercept. So these intercepts are located here at 2, 0 and 4, 0. So that means y equals x minus 2 times x minus 4. They have to be opposites of the intercepts. Keep that in mind. And then for our a value, we learned a shortcut that says if you go over 1, up 1, then your a value is just 1. And then you got to make sure it's in standard form at the end. So let's go ahead and distribute. X times x is x squared. X times negative 4 is negative 4x. Negative 2 times x is negative 2x. Negative 2 times negative 4 is a positive 8. So this is equal to x squared minus 6x plus 8. Okay. Second one over here, this has intercepts at 0, 0. And 1, 2, 3, 4, 4, 0. So this is going to be y equals x minus 0 and x minus 4. For our a value, we also learned if you go over 1, down 1, your a value is going to be a negative 1. So y equals negative x minus 0 is just x, so that's negative 1 times x, or negative x, times x minus 4. And then go ahead and distribute that in with a negative. Negative x times x is negative x squared. And negative x times negative 4 is a positive 4. And x. That would be your final answer. Okay, so that does it for the Math Around the Room problems.